Welcome back to the new video, guys. In this video, we will learn about binary search and how binary search works and the code of binary search. So let's get started. To implement binary search, there are some important things like the array needs to be sorted. If the array is not sorted, the binary search won't work. So let's take and see a scenario how binary search work. So let us consider a array here. Let us consider an array with the element inside it. Let's take any element which is sorted 15, 18, 50 and 70. So I have taken a random element which is sorted, and to perform binary search we need two pointers for it, like first low and then high. We consider a low and a high and then a mid pointer. So let's see low, high and a mid pointer. So to find the mid, here we are taking low. It's the first index we're taking as a low, and here we are taking high as the last index we are taking high, and we need to find the mid. Mid means the middle of the array. So how we find the mid? So to find the mid, there is a formula. Let's see. We can find the mid with the formula. And yes, we can find the mid with the formula low plus high by 2. Okay, but this formula will won't work for some condition. In which condition I will talk later. Okay, so for high we are taking this index, and for low we are taking this index. So if we find the mid according to this formula, we will take 0 plus 5 by 2. Okay, so it become the middle. And let's suppose we have to find 50 from this array element to find. We need to find 50 from this array. So how it will work? Okay, how binary search work? So we consider low index 0 first and then high index 5, and we have taken the mid index with this formula, and so this become 15. Now when we put a condition on it, if low is sorry, if mid is less than, okay, if less than the given element, so we will increase the mid and put it in the low. Okay, here we are taking array mid, means array mid is like 15. 15 is less than element, so it is true. 15 is less than element, so we will change the mid now, and we will change the low now. So low become mid plus 1, so 15 plus 1, so mid become this 18. Okay, and now one more condition we have to write. One more condition we have to write. If array mid is greater than element, we can also write it inside that else block. For demonstration purpose, I am writing this inside a if block. Okay, we will take, we will change the high now. High is equal to, so what we are doing here, suppose we need to find this element. Okay, it's yellow color, a bit scattered. Okay, anyways, we have to find this 50 from this element, it is present or not. So how binary search will work? It is 0 index, 1, 2, 3, 4 and 5. Okay, so the low is first 0 and the high is 5, and it is 5 by 2. First it is 2. Okay, 15. Now we will see this condition. If array middle is less than the element is now 50. Okay, element is 50, so this condition become true. Okay, so now we will change the value of low is mid plus 1. Okay, so what's the mid now? 2. So we will change the value of low as 2 in the first iteration. Okay, and now mid low become 2 and high is already 5. Okay, mid become 2. Okay, and high is already 5, right? So we will find again mid of this array. So mid of this array become this, and then we will check one more condition. Before this condition, we will give one more condition, that is if array mid is equal to system dot out dot print found. Okay, so this condition is topmost condition. Okay. So in this we found the mid 50. So it will check this condition. If array mid, so array mid is 50 is equal to element, the element is 50, we need to find 50 from this array. So we write system dot out dot print found. So this is the entire binary search thing. What we do here, like in this array, we divide. First we divide and then see array lies in which part, after mid part or before mid part. If the array lies in before mid part, suppose this is mid and it lies this part, we need to change the high. Okay, and if the element lies after mid part, we need to change the low. Okay, if we change this, and so the iteration become less, So the time complexity of this is O of n, because every time the input is divided. Okay, first time we iterate it, like every time the iteration become half. So that's why the time complexity of this binary search is log n. But one of the important aspect is the array needs to be sorted. Okay, if the array is not sorted, you can perform arrays dot sort and then perform binary search. So let's see once the code how it works. Okay, so you will get an a small idea about how binary search works. So let's go to the code and see. Let us write a main method. Okay, let us take the array. Let us take that array only. Okay, let's take the element to found. So int is equal to 70. We can take a flag, boolean flag, to see if we found the element, we mark this flag as true, and if we didn't found the element, mark this it is already false. So if we didn't found the element, it will print the element not found by the help of this boolean. Okay, so let's move to the next part. Take the low is equal to 0 and high. So earlier I talked about why we are not using this formula. This formula will give error at some part. Okay, we also take high is equal to for mid. So now I will explain you why we are not using, why we will not use this formula. Instead of this, we will use another formula. So what formula is that? So instead of this, we will use low plus high minus low divided by 2. So why we are not using this formula? Okay, let me explain you some scenario where this formula will won't work. So suppose the high value is given, the low value is given some positive integer. Okay, and high value is the highest positive integer. Okay, so when we add these two, it will exceed the limit. So this will give exception. Okay, the high integer value, integer dot highest value, and it will add one or anything, any positive number on it. So it will crash here. So that's why in this formula, if we add like low plus high minus we subtract low from that high, if the value given here the most positive integer and we subtract low on it, So it is inside the range, but it get outside the range and the program may be crash. So we will use this formula only. Okay. So let's change this formula. Okay. So this is the mid. We need to write a while loop while low is less than equal to high. If the low is less than equal to high, then only we need to perform this binary search. If the low greater than high, then we have to stop that loop. So this is the condition, and after that we will write all the condition for it. First we will write if this condition is when we found the element, and after that we need to write when we found the element we will make the boolean not boolean flag true, and then after that we have to write if array mid is less than element. Okay, if array mid is less than element, then we have to increase the low. We have to change the low, and we have to give an else part. We have to change the high. Okay, and let's format the code first. And if this condition remains true, then the element is not present there, then we have to write one more condition. Okay, let me run this code once. So see this is working or not. Let me save it first and see. Yes, element found at index 5. Let me give some value which is not present, not found. Okay, this code is working. Let me give another element found at index 1. Okay, so this is working. So how this is working, I explained it earlier. Hope you understand this code. You will implement once at your own IDE so that you will learn this. Okay, that's it for this video. I will meet you in the new video. So thank you so much. Goodbye.